This lesson is about zero and negative integers as exponents. We're going to start with the review, just a generic review of exponent rules in general. In the past, we said that m and n are positive integers and a and b are real numbers. The only exception was that b couldn't equal 0 whenever it appeared in the denominator. If that's the case, all of these different exponents are true. So let's just take a look really quickly and then we'll use these today as we look at zero and negative integers. First one, when you have like bases, we add exponents. Power to a power, when they're right next to each other, we multiply the exponents. This third one just tells you that you can distribute an exponent to both parts, both the a and the b in this case. The fourth one shows you what to do whenever a fraction is raised to a power. You're going to distribute the power to the top and to the bottom. And finally, one we'll look at more specifically today, if you have a fraction with like bases, we can subtract the exponents. So let's start here at the very top and take a look at a really unique property. The first rule I had on the previous slide was that when you have like bases, you can add the exponents. Here we have like bases, so I'm going to go ahead and add the exponents, which would be x to the 4 plus 0. That's x to the 4th. I know the only way that can happen is if this thing right here equals 1. So I multiplied it by 1 and I got itself back again. Only one way that can happen. Because of that, we have a special property that exists that any number to the 0 power is 1. Sounds really strange, but it's got to work in order for this to uphold. So anything is 1. 4 to the 0 is 1. 628 to the 0 is 1. 4 sevenths to the 0 is 1. Even this strange variable expression, x squared y to the 5th all raised to the 0, it's 1. So anything raised to the 0 power is 1. Another important property. Next thing we're going to look at is a new definition, and this is a definition of a negative exponent. When you see a negative exponent, what that really means is it's a fraction. So b to the negative n is the same thing as 1 over b to the n. Very important property. So let's go ahead and look at some examples that are like this. This is going to be the main focus then of this lesson. So x to the negative 6th, this is the same thing as 1 over x to the 6th. 2 to the negative 3, that's the same thing as 1 over 2 to the positive 3. We actually know what that is. 2 cubed is 8, so we get 1/8 as an answer. You could always type in 2 to the negative 3 in your calculator and get a value, but it's going to be a decimal approximation. Here we have an exact answer. 10 to the negative 2 is the same as 1 over 10 squared, or 1/100th. The next one's kind of unique. We have a negative exponent, but it's in the denominator already. Well, the property says we're just going to flip it the other way and use the reciprocal. So x to the 4th will come to the numerator instead, and we'll have positive 4 as the exponent. Another unique circumstance is this last one where you have a fraction raised to a negative exponent. That's just going to use a reciprocal. This will be the same thing as 3/2 to the positive 2 power. And according to our rules, this square will distribute to both the numerator and the denominator. I'll have 3 squared on top and 2 squared on the bottom, which gives us 9/4. Let's continue to look at additional examples that have negative exponents in them. The same properties, but now negative exponents. Here we have 2 like bases. So remember, we have a property that says like bases b to the n times b to the m will add the exponents. So in this one, I have like base, so I'm not going to change it. It still stays as a 2, but I'll add the exponents. That means my answer is 2 to the second power, or 4. So we do not change the base. That b remains the same, just the exponent changes. The second one is just like that. Like bases, I'm going to keep the 10, but then add the exponents. 5 plus a negative 6, or 10 to the negative 1 power. Now this is the answer, but it's not considered simplified. In all of the problems that you'll do, there'll be an extra statement that says to express your answer with positive exponents. Now you can't just erase the negative. Instead, what we'll do is simplify it. The rule for negative exponents is that we put it in the denominator. So this is the same thing as 1 over 10 to the first, or 1/10. That's the simplified answer and what you'll type in your assignments. Next one uses a rule about power to a power. That said that b to the m equals b to the n times m. So I'm going to take the exponent negative 3 and multiply it by negative 2. That's 2 to the 6th, or 64. So we're still using the same properties that we did before. It's just now it's that potential for having a negative exponent in the answer. Here's some more examples. Using a different property, the one that says that b to the n over b to the m, we subtract the exponents. These are like bases, so I'll keep it as an x and subtract them. 2 minus 5 is negative 3. It's a negative exponent, so I want to simplify it to 1 over x to the positive 3. Here, I'm going to subtract the exponents since the a's are like bases. Negative 3 minus a minus 7. Negative 3 minus a minus 7 is actually positive 4. So there's no need to change it or take the reciprocal. There's no negative exponent, so I'm going to leave it alone as a to the 4th. Here's another unique one. Like basis, I'll subtract the exponents. Negative 6 minus a minus 6, or negative 6 plus 6, which is 0. Anything to the 0 power is 1. You might have known that already when you saw back here that the exponents matched. We have the same thing in the numerator as the denominator, which would tell you that it's going to be 1. Here's some more. Go ahead and try these yourself, and then stop the video, try them, come back, and see if you got the right answer. Check your work to see if you got these correct. The first one is x to the 6th. The second one is a to the negative 7th, or 1 over a to the 7th. The third one is y to the negative 12, since we had to multiply power to a power. I changed that to 1 over y to the 12th. And the last one, I needed to use that property where the exponent got distributed to both. These changed into power to a power, so they were multiplied together. Here again, another unique thing happens. One of the exponents is positive and one is negative. So one is going to go underneath the other. It'll look like this. X to the 6 is normal, nothing's wrong with that. But then y to the 12th has to go underneath. Okay, just a couple more examples to demonstrate this. I know that 4 times 3 is 12. But then I have x to the negative 2 times x to the negative 1. I need to add those exponents. Altogether, that would give me an x to the negative 3 power. That 12 is normal, so I'll leave it alone. But the x to the negative 3 needs to go to the denominator. Last one, which is probably the most complex. I'm going to work on simplifying what's inside these parentheses first, just like order of operations would tell you to do. I know what 12 divided by 6 is. That's 2. I have like bases here, so I'm going to subtract the exponents. Negative 6 minus a minus 2. So my exponent is going to be negative 6 plus 2, or x to the negative 4. And I still haven't done anything with this negative 2 power. Like I said, this is a pretty complex problem, lots of steps. It now needs to be distributed to both parts. 2 is going to get a negative 2 power, and so is x to the negative 4. Two to the negative 2 is the same thing as 1 over 2 squared. And this is a power to a power, so I'll multiply the exponents. My final answer will be x to the 8th over 4. It's a lot of work for one problem, but keep in mind this is kind of a worst case scenario at this point, at least in terms of the most steps that you need to do. All right, try the assignment now.